Nonlinear thinking. How important is nonlinear thinking to solving problems?
Okay. Well, nonlinear systems are, let me define nonlinear systems. A linear system, let's define that first.
Yeah, let's back up.
Yeah, let's back up. It's the most simple system you can describe, and it's too simple to really describe any realistic situation that actually exists. A one-to-one, for example. Let's say you want to associate two variables together, my behavior and then your behavior. Okay. A linear system would have to say that either your behavior is completely dependent on mine, or my behavior is completely dependent on yours. So if some independent observer were to come in and observe only me, then they would be able to perfectly predict exactly what you're going to do based only on what I'm doing.
Okay, and that's linear.
That's linear.
Okay.
Now, any realistic, already we're just two people.
Mm-hmm.
You're asking about solving problems in society in general. We're just two people. Our relationship is already nonlinear because you ask me a question and my response is going to depend on what you've asked me. But then your next question is going to depend on what I just said. Yeah. And my behavior is kind of affected by the way you're behaving. You seem, I came in here pretty nervous for this interview, but you seem like a pretty relaxed person, and that helped me. So it's this sort of chicken or the egg thing, if you will.
Yeah.
Like we're both sort of evolving in time together. So that is the simplest example that occurs to me of a nonlinear system. Every situation that you can think of in society is a nonlinear situation. Historically, because it's computationally difficult to get at, nonlinear systems have been, in many areas, approximated as linear, because then they're easier to investigate. But at a certain point, that becomes to be a futile means of attack because it's not realistic. So, for example, the system that we study in terms of neutrinos emanating from a supernova event, that's a nonlinear dynamical system. Dynamical in the sense that it's continually evolving in time. Dynamical system. A bunch of neurons in the brain interacting with each other via electrical signals, that's a nonlinear system. A bunch of people interacting in a boardroom, that's a nonlinear system. Have you heard of the 6 degrees of separation rule?
Yes.
That you're related to everybody in the world by just 6, and now with social media, maybe it's even fewer. That's related to the small worlds paradigm. Do you know what I'm talking about when I say small worlds structure?
I haven't heard that.
It's the idea that there are small worlds of, let's say, people. That there's a family here of like 6 people. There's a family here of 4, and there's a family here of 3. But one of the people in this group knows one of the people in this group. So all the small worlds, if you will, are connected by very sparse connections or synapses. And if you look across different scales of things, so people, neurons...
It's taking the 6 degrees of separation, but scaling it a little bit.
Yeah, so this applies to so I just gave you the example of people.
Yeah.
But if you look at the brain, very, very similar structure. You see very tightly connected kind of wads of neurons here and here and here and here. But then there's a very skinny synaptic connection between one neuron in this wad and one in this one. So that if you zoom way out, you find that the brain is composed of very tightly connected little conglomerations, but they're all somehow connected very sparsely to one another. And then if you zoom even farther out to the observable universe, you see very similar structure, large-scale structure in the universe.
Wow.
So these are all nonlinear dynamical systems connected in eerily similar ways. So I actually, very long-term, I'm very interested in the connection between the way the universe is structured and the way the brain is structured, and the way social the way society is structured.
It's like from the brain, and then it just like keeps scaling to the universe, right?
What I mean is, yeah, you see the same kind of architecture, I guess that's the best word to use,
Yeah.
on vastly different scales. So large scale structure in the universe, tiny itty bitty structure in the brain, and then in the middle, people.
Mm-hmm.
Society structures itself in this same kind of way.
It's amazing. Huh. What's something...
But I'm not sure if I answered your question. There are people working on what you just were asking me about treating cultural interactions as nonlinear systems. If you go and Google nonlinear or small worlds culture, nonlinear dynamics society, you'll find things. I haven't ventured far into that, but it's out there. There are people actively working on this. I don't know who they are. So I'm a little bit out of my comfort zone again, but this is an active area. My point is this is an active area of research among social scientists.